Next, we need to set up total inventory, and that's because we have a requirement that the warehouse capacity of 3300. We cannot have more inventory, ending inventory than that. And that is for both the motors put together. So we have to find the total inventory, okay, ending inventory for the first motor GM3A plus the ending inventory for GM3B, and that has to stay within the 3300 for each of the 4 months. Okay. Now let's look at the costs. Okay, well, labor first, then cost. So remember, labor, we have to stay within the minimum and the maximum limits. All right. So let's compute the labor that we will need in each of the months for each of the two motors. Okay, the first motor. Okay, so that's the first one, and we're going to multiply by the labor needed for GM3A, which is that, and that has to be absolute referenced. All right. Now labor needed for B, so that is the number of units that will be produced times labor needed here, that one. Okay, again, absolute reference that. And now if you add the two, that will be the total labor that will be used. Okay, copy that over. Now it is this that has to stay within these two limits, minimum and maximum. All right. Okay, so now we are ready to compute cost. So production cost is that. We have set up the cost per unit, and this is the production. So we can do a sum product. Okay, cost per unit, number of units produced. Okay, so that will give you production cost. Now carrying cost is for ending inventory. Okay, and that cost is given here for the first motor, and this is for the second motor. So this will be sum of the ending inventory of GM3A, which is that, times that one, plus sum of the ending inventory of GM3B, okay, and that's here, times that. So that will give us the carrying cost, okay, and then we sum the two. So that will be the total cost. Okay, let's make that into currency as well. So now we have everything set up, cost and the model. Okay, now data, solver. So that's the objective cell, and we want to minimize. And the changing cells are these cells, and the constraints are available after production must be greater than or equal to demand. Okay. And this is same as saying ending inventory greater than or equal to 0. Add, and then April ending inventory must be greater than or equal to the required. Okay, so that's for motor GM3A. Then the B, okay, so this is available, and I forgot to put the label. I'm going to do it just a second. Greater than or equal to demand. Add that, and the April ending inventory must be greater than or equal to required. Okay, add that. And then, of course, your total labor, okay, the total labor, I mean, so total inventory, so will have to be less than or equal to the warehouse capacity. Okay, so each of the total inventory for each of the 4 months must be less than or equal to the capacity. So since this is just one number, and right hand side can be like that, so solver will figure it out. Add that, and then total labor hours must be less than or equal to the maximum labor hours, and total labor hours used must be at least, okay, it cannot be less than the minimum limit. Okay, so now we have all the constraints. They make unconstrained variables non-negative, simplex LP as the method, and solve. Okay, so we have an answer. So let's before I forget, okay, so this should be greater than or equal to. All right, so now at this point, okay, so we have some non-integer answers, okay, which is okay in this case because the non-integer part simply can be thought of as work in process inventory. Okay. But if you want integer answers, okay, like there are only 8 variables, so it's not a really big problem. We can add integer constraint. Okay. Remember, the integer constraints can be only for decision variables or changing cells. So solve it'll, okay, even for 8 it's taking a little bit of time, as you can see. Okay, so now we have integer answers. This is where our options will be important. So here the integer optimality is set at 1%. So which means the answer that we got here, the total cost, we can only be sure that this is within 1% of the lowest possible cost, which may be good enough because we want to be able to get an answer, because in large problems, if you set this to 0, it may take forever to solve, hours and hours and hours. So let's try what happens with 0. I have edited the video so that you don't have to wait for so long. It really took much longer, like maybe 2 or 3 times longer than when we had 1% as the integer optimality tolerance limit.